I'm recording now. What have we done so far? Nothing important. We just created this level -10, and we created a level 0 here. And now on this level -10, we see that well, we don't see the grid lines. So I told you that if we create this scope box um, here, mm, let's make it smaller. Now that scope box, it's here in all these layers that we have created. Okay, can we control the height of the scope box? Yeah, we can. Well, and these are all the things that are visible in that box. If we don't have grids here, we have to go to a level in which we see the scope box and the grid lines. We select all the grid lines, and we connect all these grid lines to scope box 1. It's the one we have created. The highlighted okay, and now we can see the grid lines here. Why does it happen? Does it make any sense? I don't think so. But we have to get to know Revit little by little. So that scope box, it's something that works. Sometimes there are things that disappear. There are reference lines or grid lines or levels or reference planes that disappear from one view to another. So if we create that scope box and we connect the element that we want to see to the scope box, then it will work well. And now I think we will have that scope box everywhere, and we can edit it, make it bigger or higher or lower. Okay, so now we can associate things to that scope box. We have the grid lines here, and for the basement, I want to try something different. So on that basement, okay, in this east elevation, we need that span because this is the basketball court, but the basketball court starts here on level 0. So this is a basement. Do we need this span in a basement? We don't. And if we don't need this huge span, we better create a different structure, because having elements or creating elements with long spans, it's very expensive. So it's more convenient to create columns here. Since we are in the basement, it's not a good idea to expose steel structure to the soil. We have to use concrete elements. If we are working in a basement, it's better using concrete elements. You can use steel elements as well, but then you have to protect them against water and against other attacks like bugs or corrosion. I don't know. There are many things that can affect steel structure when it's underground. So we have to use what we have to use. We have to use concrete walls. Can we go down with the steel structure up to this footing? We can, but we have to cover this structural element with concrete. We are going to do that, and at the same time, this is underground. We need a retaining wall here. A retaining wall is a wall that retains the soil, because we are digging and we are excavating basement under the grade level. Do we have these kind of things? Do we have walls? We are not working with that, architecture. We are working with the structural discipline. So in the structural discipline, We have structural walls, and here we have different, and we do have a retaining wall. Okay, so select this retaining wall, and we have to place this retaining wall here and make sure that it's thicker than the structural element. So we are protecting this steel structure with concrete, which is fine. We have this, and as always, Revit has created this concrete wall somewhere. Okay, so underneath this level. Why? And we will have to go from level -10 to level 0 and no offset. So this is a concrete retaining wall that is, first, it's retaining the soil that we're going to have here, and it's protecting, at the same time, it's protecting the steel against the water and everything that we can have underground. Now we have to do this all around this building. So create retaining walls like this, and but why? Yes, -10 up to level 0. If we create retaining walls again, okay, so I'm going to, it's up to level 0, no offset. Top constraints invalid for the level. Okay. Let's do this and this, then go to perspective and select this one and that one, and now up to level 0 and 0 offset. There you go. And now we can trim. We can select this and we can trim these walls. This is my retaining wall around the building, and then there will be soil here, and then this retaining wall will retain, it's a structural element that retains the soil. But if we are using this retaining wall, I think it's better if instead of having these beams, because the beams work well when we are working with footings. But when we have a retaining wall, we need a footing, a wall footing there. So I'm going to delete all these beams. And I'm going to select structure, structural foundation for walls. And I only have to select the wall here, and we have the footing. There you go. And on the perspective, yeah. So we have the wall, and the wall is resting on this footing. And we have to reinforce this because here we have the structural elements. So we need an isolated footing, but that's fine. We can have isolated footings, and then we have a footing for the wall. And then if I need a reinforcement here, that works. And what I'm going to do now is to place concrete footings on this area of the basement, because on the basement we don't need that huge span. We need that span because we have a basketball court on the first floor, but not in the basement. I'm going to insert columns So I inserted these either round or square columns. Let's do it with square. 12 by 12. Okay, 12 by 12. And I'll place one here. And now we have to find out where it is. Perspective. Okay, it's underneath. It has to go to from level -10 to level 0 and no offset. And now we can copy. Now that we are sure that the column is where it has to be, now we can copy these columns at the intersection. Is this enough? If we have columns here, now we need footings. So we need isolated footings here where the columns are. 1, 2, and 3. So let's see if it's in the right level. Yes, it is. Okay, so we have concrete columns and footings there. And they are connected with this beam. That's fine. And now we can copy all these. We can copy the columns, the footings, and multiple, and we just copy. Okay, so that looks like a real building. We have a basement. In the basement, we don't have a cord. We don't need a long span. And we can have concrete elements, concrete vertical columns. And then we need footings underneath. I'm going to do the wireframe. Okay, so that's it. We have a concrete wall, a concrete retaining wall, concrete columns here. And here on level 0, there will be a floor. Okay, so we will have a floor here. And actually, we need another floor here on the basement. So let's create first the floor on level 10. We are in the structure, so let's create a floor, structural floor. The metal deck is better for is the best option for the steel structure, but I wouldn't do a metal deck here. I would create just what do we have? A generic floor. It will work well. So I select this corner and this corner. I click OK. And now I don't think it's in the right level. Yep. Yep. The floor is there. It's on level -10. But it has to go up. When we create a floor, you know that we start from that level and we go downwards. So we have to do the other way around. In this case, we have to go upwards. So we use a line. And now this is the floor. Okay, so this is the floor element. The floor is resting on the footings. And that's it. Yep. And then we need another floor on level 0. Let me see view range. Bottom offset. Let's say -2. -2. Okay, so here we see where the floor should be. So I'm going to go to structure, now the floor, this generic one, rectangle. And attach everything to this floor. And now the retaining walls and even the concrete columns will be attached to that floor. Okay, so we see that the height of this column, it starts at the footing level, but then it goes to the first floor, to level 0. What is the height of this? 7 feet. Well, it's a basement. 7 feet is 7 feet and 4 inches. That's fine because this can be like a storage room, or so it doesn't have to be something. So we don't need 10 feet in the basement. We might need a 10 feet, but I mean, I think 7 feet is okay for this basement. Okay. This is the basement. So we have created this basement. It will be underground. From the structural point of view, everything is feasible. I mean, we have a retaining wall here. Then we have isolated footings where columns are, steel columns are. And then we have isolated footings connected by beams where the concrete columns are. So everything looks well. We don't have a span where we don't need it. This is much cheaper than creating a slab without any columns. And now, upon these foundations, we can build the rest of the building. And what is the rest of the building? We're going to need the envelope. And the most challenging element is going to be the roof. Okay, so we have to figure out how to close this, because so far we have the structure, but now we have to close this. So, we can get the light, natural light from these elements, and but at the same time we have to get rid of water. If you see, if it rains, the rain will go to this way, and then we have to get rid of that rain in these 2 lateral walls. But we will think about it later. So far we have the footing, the floor slab, retaining wall, and then the first floor here.
Do not develop my app on your intern's forehead. Why you want to develop one? I'm glad you asked that, Jerry. So you don't develop this app. Flutie, go make some photocopies of something. Oh, well, if anyone wants.
Well, I'm muting a lot of people, so if you want to interrupt me and you want to ask anything about the project, do it. But if you are not talking about this, just mute your mic and we'll do better. Okay. I wonder if I should show you now the how we get rid of water here in the basement, or we shall continue with this. Okay, so let's work with this floor first on this east elevation. This is a floor. It can be concrete. We have this generic floor. we can edit type. Let's duplicate. And we're going to create a generic floor, but made of concrete. Well, this is the floor, the court floor. Dimensions, we can keep this thickness, but the structural material, it has to be concrete. Cast in place. And then for the thickness, let's say is a foot. And then we need the flooring. It's not a structural element. It can be a finish, and a basketball court needs like a wooden, do we have oak or oak flooring? Well, I don't know what kind of wood we have in basketball courts, but oak looks fine. And let's say 2 inches. Yep. Do we need thermal insulation here? Well, it depends. Someone might say that having thermal insulation, if this basement doesn't have a heating system, we might need a thermal insulation here. Okay, or we can place the thermal insulation in this retaining wall, and we can place the thermal insulation underneath that slab or on that slab. I don't know. Either way, works. I think since we have a lot of height here, I think we can place a thermal insulation on that wall. So let's do it. So let's edit type, and let's place thermal insulation. Let's insert up, down. It is not structure. This is thermal, and this can be rigid insulation. And this can be how many inches? 4. Okay. Interesting. We have here, why do we have these units? Manage project units. They are all, I don't know. Anyway, with if you do this, make sure that your if you create a floor here, make sure that the R value of this floor is above 50, not 50, sorry, 30, because it's a floor. It can be 30, but these are not the units. Those are international units. It has to be hour, feet square, Fahrenheit divided by BTU. Okay, so make sure that it's above 30, and because this we are even in visual representation, we're meeting passive house standards. Okay. There you go. So we have the floor, and then we have this. So now we need to create another floor here. On level 12. And since we are on level 12, we have this floor plan. So let's open level 12. The floor is going to be here because this is like the entrance. So we have this overhang, but this is going to be okay. So let's make this floor all this. So we have to create structure, floor, and now we can select the metal deck because this is the right floor. That floor goes well with this steel structure. And where shall we can start at this point, and then we can finish. We don't have a reference here. Okay, so let's align things to the grid. And to this grid. There you go. Okay. Now let's see the east. Where is the east elevation? East elevation. Okay, so this is the metal deck. You see that we have this shape here, but I don't like it because I want to move the metal deck up. So here we select the shapes. If I select this and I filter, I want just the floor. No, let me see the 3D view. Okay, this is the metal deck. It's on level 12, but I need an offset here. So let's make an offset 2. And I think this metal deck, I will analyze the structure. It's structural deck, the metal deck, and concrete cast in place. That's fine. 8 inches, I think it's too much. Let's make it 6. 6. 6. Apply. Yep, the proportion is better now. And then we can align. We have to place this on the top of these beams. So now our metal deck, it's just on the top of these beams. Yep. So we have columns here and there, and then here we have an overhang. Or I'm going to try something different. Because yeah, this is going to be the entrance to the building. Okay, this one. And the entrance is always something something special. So if we have the entrance to a sports facility, yeah, we have to try to do something special here. And okay, so on level 12, I'm selecting the metal deck, only the floor. And I'm going to edit boundary. And I'm going to this is 1, 2, 3. So there's a midpoint. Okay. And now I have to trim. And now I have to trim these 2 lines. Okay, so this is what I'm doing. I'm just creating like an opening here, and this is going to be the entrance to the building. Yep. So I'll do something special here at the entrance. The entrance will be on the first floor here, and then yeah, so there will be something there. Okay. So now on level 0, I'm going to create, if this is the court, there will be like locker rooms for men and women. So I'm going to do something symmetrical. I'm not going to do crazy things. So we have architectural walls. This is not a retaining wall, so we can create a interior partition. So we can create interior, this one. And here, working with the grid lines. But first I need to know where this is. This is from level 0 up to level 12. Okay, great. I trim here. Let's see what I'm doing. Oh, okay. Now it is supposed to be from level 0 to level 12. Why do we have level 0 to level 12? 0 sub-constraint. Okay, so we have this for the locker room, and now I'm going to mirror. No, not there. I'm going to copy. Here. Okay, so this is the entrance to the building. We have locker rooms here for ladies, for gentlemen. And since we have different floors, we're going to need staircases because we have to go down and then we have to go up. So this is the entrance, and then we have to go up to this level, and then we have to go down. So let's create a space for staircases. And we can do that in all these floors. Okay, so in this floor, I'm going to edit boundary, and I'm going to open this space. And this one. Right. Okay, so there will be staircases here and there. And if we want to get to this floor, we have to do the same with this one. So on level 12, I edit boundary, and I need exactly the same opening on this floor. Here and there. Oh, if this is a staircase, for sure, we don't need beams. We have to unpin those beams and then we can delete them because they belong to a beam system. Okay, so we need to get rid of those. Select the beam, unpin, delete. Beam, delete. Okay. We have the, I'm going to, I want the section. So view section. Okay. And where is the section? Section 1. Okay. So in that section, we will have this opening for the staircase. I think there will be another, yeah, we have another opening here. So the staircase will go here up to this level. And yeah. Well, we have to continue this roof. Okay, so it looks like, do not underestimate the importance of symmetry. Okay, so if you have a symmetrical building, sometimes we tend to think that it's boring, and maybe it's true, but there are a lot of examples of boring buildings that are good. And I don't know if I had uh, uh, to tell you who the master of symmetry is. I think it's Mies van der Rohe. Okay, this guy, Mies van der Rohe. If you look at their buildings, they are all, well, symmetry is important. Okay, so he's the one who is, if you want to work with steel structure, you have to know the work of this guy, because he reduces the elements to the minimum, and everything is beautiful. Everything has a good proportion, and from the structural point of view, it works. And buildings are symmetrical. So this is the Crown Hall in the Illinois Institute of Technology. Let's look at this building. Crown Hall plans. Yep, there you go. Someone might say, okay, this is too simple. Okay, it's simple, but it works. It's symmetrical. Everything is symmetrical. So you have two staircases, one at each. You have whatever is this, probably the restrooms. This is the entrance. The entrance is at this axis of symmetry. Everything is simple, but it works. And this building, it's in history of architecture. So do not go crazy trying to create something unique. Sometimes something symmetrical can be unique. By the way, this is the basement plan of that building. It's not that symmetrical. And of course, if you have a building that it's an open space underneath, you need to have the restrooms, or you need to have the storage room, or whatever program you might need. Okay, but we are trying to, if we are working with steel structure, I think this is a good architect to copy, because he worked with steel structures, And he doesn't complicate plans, and he doesn't do anything crazy. But at the same time, everything is it works perfectly well. And that would be the section of the building. So this is the Crown Hall, and he has other symmetrical buildings like what you call it? It's in Berlin, National Galerie. No, this is the old one. Okay, the Neues National Gallery. Yeah, there you go. So this is the building, as you can see. It's nothing. It's just a roof that floats, and here we have a glass envelope. So this is it. So in when it's dark and you have light inside, you see that well, the building is just the roof. Okay, and then we have structural elements for sure, but that's it. It's very simple. And if we study the plan of this building, yep. So this is the plan. Again, symmetry, uh, staircases, restrooms, and that's it. It's a building that you can enter the building anywhere, so it doesn't have a door, so you can enter the building from anywhere. And on the basement, well, it's difficult. Well, it's different because you have a program on the basement with concrete columns. Okay, so you have an open space without any columns on the first floor, and all the program, all the offices, all the storage room, or all the things that you need here, it's on the basement. So this is a good way to copy, or this is a yeah. So these are more pictures of that building. And where does it come from? So do you think that this guy, Mies van der Rohe, when he was living in the early 20th century, he said, okay, there is a light bulb that goes off above my head. I have a great idea. I'm going to create an open space here, and I'm going to create a basement with a lot of walls, partition walls, and concrete structural elements. No, it comes from um, the Saint-Chapelle in Paris. Okay, I'm sure you have studied this building in history with Donna. And what is it? Well, it's the same. So we have an open space here with a lot of light, and then we have a dark basement with a lot of columns. Okay, so and this always works because contrast always work when it comes to architecture. So if you enter that building through a very dark space with low ceilings, and then you go upstairs and you find something like the Saint Chapelle, like this, full of light and with no columns. Uh, so you appreciate this space because you come from something that it's just the other way around. It's dark and low, and then suddenly you go upstairs and you are in a different space. So that is contrast, and it always works. And what is the plan of the Saint Chapelle? This it's nothing. It's symmetrical, of course, and that's it. So we have structural elements here and there, and we have an open space here. Okay. Mm, mm, Sometimes the best ideas are very simple, and I think, well, I don't mean that this is the best idea, but I'm trying to do something symmetrical, and it will work. Okay, so we have the entrance. The entrance is in the axis, and then we enter through. where is the elevation? Okay, so this is the entrance. So this is a low space. We don't have a double volume here, and suddenly you end up being in that space, which is the basketball court. If you go through the restrooms, that will be here on level 0. Okay. And this kind of strategy, especially if you are working with this kind of steel structure, it always works. Okay. So we are still working with this Revit file. Footings, the structural wall here, the retaining wall. Then we need a floor. So this is the basketball court floor. We need openings here for the staircase, and that will be the entrance to the court. And these are the locker rooms for, yeah. And here we will have like different, if we go upstairs, there will be offices, or I don't know. So there will be something on that floor, but there will be partitions and there won't be structural elements. We will define this next week. Okay, so now we need the envelope. So what kind of envelope are we going to have here from this floor to that floor? So I'm going to copy something. Last year, I remember that I copied, well, we copied in this course, this Louis Kahn, yep, Yale Art Gallery, and this is okay. So this is the one we are going to copy. Why are we copying this? Well, because I like it. And again, it's something very simple. So we see the structural elements here. We see the structural elements. And if you look at this, it's divided. So we have openings and we have opaque elements. And these elements are divided in 6. So you see that we have 1, 2, 3, 4, 5, 6. So we will do this, and I'll show you how to work with these parts and how we can divide these parts. At the same time, we are looking at the structural elements. And okay, so we need a grid of structural elements like this, and then we need to divide this. This would be a terrible thermal breach, but we will solve it inside. Okay, so we will place thermal insulation inside so that we don't have a thermal breach, and we can see the structural elements here. So that's the idea for the envelope of this building. And then we can create, we are free, once we have the grid, we are free to create different openings here with different dimensions. And that's another thing that we have to learn. Sometimes constraints are good to design. If we are free and we don't have any constraint, we end up doing nothing because we have a lot of possibilities. So sometimes if we have constraints, we work better, because by abiding by these rules or by abiding by these constraints, then we can create and then we can modify different things. So having grids, it's grid. It's a grid. Is it boring? No, it's not boring, because within the grid you can do whatever you feel like. But you know that this is not negotiable because we have a grid, so that element is fixed. Now, what can we do in this element? We can do different things, and this is what we are going to do in this project. We are going to create a facade like that, dividing this, and then we are going to work with these panels, and we will use Revit to define the materials that we have in these panels. Okay, so first, if we want that grid we will need other structural elements around this in the perimeter of this. So can we extend this beam? This is on level 12. Let me see. Okay, yeah. So this is what I wanted to do. I'm going to extend this beam here, the other one on level 12. There. And now we can copy. Have I selected the right one? Yep. I can copy all these elements. Level 12. Copy here. Okay, there's one missing. Level 12. Okay, so this is what I wanted. And now I want to create another one there. So I have to copy all these. On the east elevation, I want to place them. Copy, remove constraints, and now I want to copy on that level. Okay, so that beams are placed here just to hold the envelope, but it doesn't have any beam. So this is a cord and it's open. So we have this here, but it's not, I mean, this is an open space. So this is only the envelope. And now I can copy this one, remove constraint here. And I can go, yeah, this way. Okay, and I need one more. I need to copy this side. Level, this is not level 12, this is level 24. Copy from this point to that point. Okay. So now we have this grid, and on that grid I can start building the wall that I want. Do we need? Yes, I think we need something. We need a vertical element there. So can I copy this on the perspective? I want to copy this one, and from the east elevation, maybe the west. Come on, I want to copy this. And now I don't see the grids. So I'm going to use the level 2, 3, and there you go. Okay, so I have created like this grid or this cage, and now I would do different things on these rectangles or the squares on that grid. Oh, I need, well, that will be different because here I don't have a horizontal beam. So there will be something different uh, for these openings that are not rectangular. Okay, so we will figure something out here. And we have to create that. I told you that now the challenge is going to be to create those roofs and the roofs here for this beam system. Okay, so now I'm going to create a wall with different parts, keeping in mind that I want to see the structural elements like this. Okay, so the wall is not going to go from this point to that point. I'm going to fill just each rectangle with that wall. So let's try to do this from level 0. Yeah. Okay, so here we have the structural elements, and the wall is going to start here, and then it's going to end there. I don't want to hide the structure. I don't want to hide the structure looking from outside, but looking from inside, I have to hide it because otherwise there will be a terrible thermal breach here. Okay, so that's the challenge. I want to do something like this, but without thermal breaches. So how many layers do we need? Okay, so let's create we can change now the discipline. We have been working with this when we're working with the structural elements. The discipline structure is good, but now I will work with the architectural one. And I'm going to create walls, and I'm going to see what kind of walls we have. Masonry. Okay, so let's start with a generic, and we are going to edit type, duplicate, and this is basketball court wall 1. I don't know if there will be more than one. And let's edit this. The structure. What is a structural element, or the where it is the between these two core boundaries? Okay, so let's use the concrete masonry unit. We know how to do that. So we're going to use the concrete masonry unit. The thickness, you know that it's either 4, 6, 8, or 10. Let's use 8 inches. A concrete masonry unit, 8 inches. Now we have inside and outside. Let's insert. It's outside the core boundary, and this is not a structural element. I want to use, okay, there will be an air layer. Now let's use rigid insulation. We always have to use rigid insulation. 4 inches. insert an air layer, air, a couple of inches, and then this material is steel, okay? Just steel, not stainless steel, but something, yeah, something very brutalist, by the way, another word. Um, so I'm going to, no, this is air. Air, okay. 1 inch, no, I said 2 inches. And finally, I'm going to insert a finish. And this is going to be, do we have something like steel? Metal deck, metal frame, stainless steel, polished, steel carbon. Well, let's use stainless. It's a safe bet. And this is 1 inch is too much. Let's say ½ inch. And inside, we go down. There will be another rigid insulation. And 4 inches, 4 and 4, 8 inches, I think would be enough. And finally, we need the finish, internal finish. Can be, I don't know, let's say wood, plywood, yeah, plywood. Inch. We preview. Okay, so we have the concrete masonry unit, 2 layers of thermal insulation, the plywood, air, and this stainless steel. Okay, so now we're going to work between these two columns. This column and okay, and this. What is the height of this? From level 0 to level 12. Is it 3D view? Okay, it's here. Well, it's here, but probably we have to attach the top base to okay, I want to see the structure, so I have to attach the top base to the bottom of the structural element. Okay, so this is it. And now, if we look at the plan, level 0, where is it? Okay, so what I want to do now is to align this face to, okay, I can't do that. Can I move, yeah, from this point to that one? Okay, so this is going to be the thermal insulation. This is going to be the brick. And I want to go to cover this with 4 inches of thermal insulation. Okay, so that's why I'm doing this, because I want to go so that we don't have the thermal bridge here. So we see the structure from the outside, but here we will see the thermal insulation with parts. Okay, so now I have decided the position, and then I can copy. And then on my 3D view, I have this. Well, we're running out of time, so I'm going to show you what to do with the parts, and then next week we will finish this. I'm going to post a classwork today as well, so you have to submit at least the structure of this with all the floors, everything we have done so far with all the steel columns. I want the concrete footings, the concrete retaining wall, concrete columns on the basement. Okay, so I'll write down what I need from you, but by next Tuesday, I want you to submit this file, because we will start defining the envelope and creating other things for the envelope. So we will have like a grid like this, and every single, not every single rectangle will be different, but we will create different things in different rectangles. But I want to show you what to do, what I want to do today. So let's do this. We know that we create parts, and now we have different parts. We have divided this in different parts. Okay, and now I'm going to try to do something like that. As you see, we have different, we have a division, so we have different elements here, basically because I can't have a steel plate with this dimension. It's too heavy, it's too risky, so I divide this in different elements so that I can work with them easily. And how can divide this in Revit? Well, it's easy. First, we have to divide parts. Okay, so now we have different parts here. On level 0, remember that apparently we don't have parts because parts usually are hidden. Okay, so we have to select one of the parts, right click, and hide in view the category. And now there will be different parts in the plan, and then there will be the same thing in the section. Why do I want to do this? Because I told you that I want to extend the thermal insulation in this direction, and probably this wood wall in this direction. Okay, so I'll do the same with this one, and I don't have a thermal bridge because I have thermal insulation here, and from outside I'm looking at the structure. And we have to figure out what to do here. So probably here, in this case, we will have to move this here, move, oh yeah, this element there. And I would like to, can I hide element? Yeah. So you see that I have hidden the wall, and now I can see only the parts, because we have two entities here. We have parts and we have the wall with all the layers. Okay, so if I want to work only with the parts, I have to hide it in view, the wall. Okay, but I want to show you the east elevation. Yeah, this is the, I think if we shade it, yeah, this is the panel we are working with. Okay, and I want to divide this part into different elements. I think the best way to do this is by using reference planes. If I use a reference plane here in the middle, I have to name it. So this is vertical 1. And then I'm going to use 2 horizontal reference plane. So I have a reference plane here, horizontal, and another one there. So this is horizontal 1, and this is horizontal 2. If I want to make them at the same distance, you know that we can use annotate, align. I select this one, that one, that one, that one. I place it here, and then I make it equal. No, equal. And now all the distances are the same. Okay, so we know that we have these reference planes on the 3D view. I know that I'm working here. So I select now this. This is just the last layer, the stainless steel. Yeah, and then I use divide parts. So if I divide parts, I can edit the sketch, but I can use intersecting references. So we have created the reference plane. So I can use levels and I can use grids or reference planes. So in this case, I have used reference plane. So I select the 3 of them. I apply, and we have different elements. I click OK. And as you can see, those are individual elements. So it's quite, this is quite useful because if I want to divide a wall in different panels, so I can do that easily. And this part, if we delete this, we delete everything. So I don't recommend you do this, but you can exclude part. So if you want to open something here, let's say a window or whatever, then you can open a window on this element. Why are they doing things so ugly in the Revit? Come on. Okay. So this is it. And now if you work on the east elevation, basically we can do whatever we feel like here. So in this one, you want to create a different division, you can do that. You can use those reference planes, or you can use a new reference plane. It's by the way, I think I didn't do it because I want this, this, and this to be the same. Yeah, now they have the same dimension. But then now you within that grid, you can do anything because you can use different patterns or different divisions for each element. And this is what this guy is doing here. Okay, so we have horizontal openings, we have vertical openings. So within that grid, then you can do different things in different openings or in different parts of this grid. And there is something interesting we can do with this, is that we can displace elements. Okay, if we displace elements, we can see, and then if we select path, okay, so we can have these exploded views in which we are looking at different elements. And this is very useful because if we look exploded views in Revit. So we can define details like that. Okay, so we can see a lot of layers by displacing layers. And this is always, yeah, so this is always something that gives a lot of information about the detail that you are creating. Next week, we are going to work on that model, and then we will create exploded views like this, and then we can define all the materials and all the layers that we have in roofs, in walls. Okay, so we will create an axonometric view like this, and we will start defining different elements, this wall, that wall, the roof, by doing this kind of exploded views. This is what we are going. So, but first, we need to make sure that we have a feasible structure. We have grids, we have columns, we have footings, we have retaining walls. So this is that looks like a building. Then if we are working with steel structures, creating grids and having symmetry, it's something good, because there are a lot of decisions that are already made because of the grid and because of the symmetry. And finally, we have to define different envelopes. Here we will insert windows of different sizes, and then we will create different divisions for these materials. But I think if we create parts first and then we divide different parts in panels, well, that's great.